Alright guys, welcome to the physical and chemical properties and changes lab. So the first thing we are going to do is mixing the silver nitrate solution. So this is zero point 0.1 molar silver nitrate, and we are going to take a piece of copper wire and add silver nitrate to this copper wire. This was the growing silver experiment that we did in second week, lab 2, same experiment. So we have silver nitrate solution, and I did a piece of copper wire in it, and then I'll let it sit here for about 20 minutes, and we'll come back and look at the silver growing on the copper surface. So this will be our silver, growth of silver. So next thing we are going to do is we are going to look at the difference between a wet ice and a dry ice. So what I'll do is I will be adding the wet ice and water. I'm going to add water to my wet ice. So this is just showing the difference between a wet ice and a dry ice. So the wet ice will just make it melt. The dry ice. Let me add to the dry ice. Let's add the water. Dry ice is solid carbon dioxide. As I add the water, so it's basically converting from the solid to a gas. So this is dry ice water, this is wet ice water. So you can clearly see the difference between the two. Right, so dry ice water, wet ice water. So now let's take the wet ice and let's add the acetone to it. Acetone. So I'm going to take acetone and add it to the wet ice. So this is my wet ice with acetone. Basically, they are just again, this will also help the wet ice melt. And I have another piece of dry ice. Take the wet ice, dry ice, and then add okay, so this is my dry ice with acetone. And this is my Okay, so observe the difference between a dry ice and a wet ice. And record it in your lab. So this is the dry ice with water still. It's converting from solid to gas. So now the next thing we are going to do is we are going to heat a piece of copper. See, I have a copper wire. Yes, looks bright red in color. So let's heat it. Yes, this is my burner. I'm going to heat my copper wire. Alright, so you can clearly see. So this is the wire after heating. Okay, so wire after heating, it appears black in color. And this is my copper wire before heating. This is before heating. This one is after heating. Okay, before looks bright red in color. After heating, so I see a layer of black mass deposited on my surface of copper. So that's copper heating of copper wire. So reaction of copper. So now think about what is going on. Is it a physical change or chemical change? So you can think about it. So let's go and look at the case of iodine. So we are going to now heat iodine. Okay. In this evaporating dish, I have ice water. As you guys can see, I have ice water in here. So I'm going to take a few crystals of iodine. This is my iodine crystals, iodine. You can see they appear. They are solid, appear black in color, right? Let's cover the gas and heat it. As we heat our iodine, it should also sublime. So it should change from solid iodine to a gas. And as you can see here, you can see that now the purple gas is forming. So it gives a brilliant purple gas, as you can see here. So keep watching. And I have added the ice water on top so that the iodine that has converted from gas to solid gets deposited back on the bottom of that evaporating dish as a crystal of iodine. Okay, so let me turn off the gas now. So it looks like we have heated okay, so you guys can see the purple vapor. So that's the purple vapor of iodine. And then, so if we were to take this evaporating dish, so you can see the iodine vapor, right? So that's why we are doing this experiment in a hood, fume hood. So that's the iodine vapor, and we can see that see this bottom here. So these are the solid iodine. So it evaporated, and since I had cold water in here, so that cold water, the surface was cold, so the vapor got deposited back as a crystal of iodine. So we witnessed sublimation, which was conversion of solid iodine to vapor or gas, and then we witnessed the conversion of gas back to solid, which is deposition. So that's our third experiment. Now let's look at the next experiment. So I'm going to take a plate with some wells, right? And what I'll do is I'll be adding some barium sulfate. So this is my barium sulfate, and then I'll add not barium sulfate but sodium sulfate. I'll add sodium sulfate, and we'll add barium nitrate to it. So I'll add 5 drops of barium nitrate, 5 drops. 1, 2, 3, 5. And I'm going to add 5 drops of sodium sulfate, the same well. 1, 2, 3, 4, 5. And let me show you guys. So the well, so that well, so this is the well I had. This is the well I had, and both my solutions were clear, right? And I got a white solid appear. Okay, so this is my white solid appearing in my well. So white solid. So let me do this. So it's a little difficult for me to use that well. So instead, I'm going to use a test tube. So I'll take 5 drops of barium nitrate. See, this is clear. This is clear. I'm going to add sodium sulfate to it. Okay, so you guys can see that I got a white solid precipitate. Okay. So barium nitrate and sodium sulfate, when we mix them, we get barium sulfate and sodium nitrate, and barium sulfate is not soluble, it does not dissolve. So that's why we see a white solid. And if we let it sit for a few minutes, we should be able to see the solid separate at the bottom. Okay. So let's leave it for a few minutes, and then we'll come back and see the solid at the bottom and a clear top. We'll be watching that in a few minutes. So next we are going to use a zinc, and we are going to react it with the hydrochloric acid. We have 4 molar HCl. I have HCl, 4 molar. So we are going to mix those together. So I have a piece of zinc, it says mossy zinc. So to the mossy zinc, I'm going to add HCl. Okay, and what I can see here is I can see that some bubbles appear. Okay. I can see bubbles appearing. See if I have a black background. Okay. So maybe on this background. You guys can see that uh, a gas is forming. Okay, so let's say I have a black wallet. Uh, okay, so you can clearly see that the bubbles are appearing, right? So what's going on is that zinc is reacting with the hydrochloric acid, and the bubbles is the bubble of hydrogen gas. Hydrogen gas. Okay, so zinc and HCl react to give hydrogen gas. So that's the reaction we learned. Okay, so zinc, mossy zinc reacts with the hydrochloric acid and gives us the bubbles that you can see here is the bubble of hydrogen. Hydrogen. All right, so the next thing we are going to do is we are going to take the sodium chloride, the table salt, sodium chloride, and add water to it, and then we are going to add water to calcium carbonate as well. So it says do it in well. It is inconvenient for me to store it in well, so I'm going to use a small test tube instead. So I have sodium chloride. So let me go grab a spatula. It will be much easier for me to add. I'll be right back. All right, so let's try dissolving sodium chloride with water. I'll take a scoopula full of sodium chloride. This sodium chloride table salt. This is my distilled water DI. If I take the sodium chloride and add water to it, so you have experienced that if you dissolve sodium chloride in water, if you take a teaspoon full of salt and put it in water, it dissolves, right? And the same thing I'm seeing here. So adding the salt to water, it is dissolving. It dissolves. So this dissolves. So let me do it with calcium carbonate. This is my calcium carbonate. Calcium carbonate. Okay. So if I add it to water, okay, calcium carbonate and water. So looks like it does not dissolve. Okay, so it could not dissolve. I can see the white solid, and it does not dissolve. This is number 6. So adding water to sodium chloride dissolved. This is clear solution, right? Adding water to calcium carbonate did not dissolve. So let's move to number 7. So number 7, it says add sodium carbonate and vinegar. Okay, so I have sodium carbonate solution, sodium carbonate. Okay, I added 5 drops. And I'm adding vinegar to my sodium carbonate solution. Okay, and the solution appears clear. So let me add a little more vinegar. Okay, I see small bubbles appear at the top, and that bubble could be the bubble of carbon dioxide gas. So the sodium carbonate has this CO32 minus, and that CO32 minus react with the H plus from the acid and gives carbonic acid, and carbonic acid dissociates to give water and carbon dioxide. And looks like I see some bubbles at the top, so that bubble could be the bubble of carbon dioxide gas forming. So that's our number 7. So the next experiment, it says take the benzophenone out of the hot water. See here. I'm heating the benzophenone. So this is my benzophenone. I'm heating them in hot water. Benzophenone in hot water. So it says take them out of the water bath and then leave them in the test tube rack for 5 minutes and observe them. Let's bring this one here closer. So this is the benzophenols. So you want to watch it, what happens. So this is the benzophenols, this one here. Okay, so this one is the benzophenols in the test tube. Watch it for 5 minutes, what happens. And this is the uh, growing silver, as you can see here in the copper. So we have silver growing all over the copper. So growing silver. So this was the copper before, and now I see the silver growing all over the copper. So watch this test tube for 5 minutes. All right, so it's been a few minutes. Okay, so it's still hot. So I put it in the background, and then in the meantime, I'm going to I'll let you guys look at it at the end. In the meantime, I'm going to continue with the next couple of experiments. Uh, or I can let you watch it for 2 more minutes, and then we can do it. So watch this tube for 2 more minutes. Alright, so what I'll do is I will take the picture of the benzophenone as it solidifies later and share it with you guys. So let's move on to the next experiment. So I have vinegar solution. So this is my vinegar solution. I'm going to add the vinegar, 10 drops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've added 10 drops of vinegar. I'm going to add the phenolphthalein. So this phenolphthalein is called an indicator. It's colorless in acid. Vinegar is an acid, so it's colorless. And if I add it to the base, it will be pink. So I'm adding 2 drops of this. And I have the sodium hydroxide solution, 0.25 molar. So what we'll do is we'll add this sodium hydroxide to this vinegar solution with the phenolphthalein, and we'll count how many drops does it take to convert the solution that is colorless to pink. Okay, so let's count. So 1, 2, 3. So as you can see, the pink appears, but if I shake it, it disappears. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, still disappearing. 21, 22, 23. Okay, 23 drops so far. 24, 25. Okay, so it took me 25 drops for this solution to go from colorless to pink, and now if I shake it, still the pink stays. Okay, so that's my reaction of sodium hydroxide and vinegar. The last one, so it asks us to take a look at the copper and graphene carbon. So this is my copper. So there are some copper strips. As you can see, they are like copper nails. So record the color of the copper nails, and then it says just manipulate the samples. So this you can see that the color is bright red, brick red or bright red, right? And this is my carbon graphite, and it looks like a powder to me. It's a black powder. So if I shake it, so this looks a powdery form to me. So that's the all experiment, and you guys take a look at it. So this is the copper, silver growing on copper. So this was the barium sulfate. So see, the barium sulfate is here. So this is the calcium carbonate that did not dissolve. And so that's it. And what I'll also do is I will take some pictures of things, and then we'll share it with you. Okay, so that will be our physical and chemical properties and changes lab. Come on.